Let's install the Dart SDK using brew on Mac. We'll register the Dart repository by running brew tup.lang/dart. And this now enables us to install the SDK. Alternatively, you can install the dev channel version by passing the development flag. Once the SDK is successfully installed, create and open your working folder in your editor of choice. We'll begin by creating a pubspec.yaml file. This file contains metadata about a Dart project. We will enter some basic information about our project such as a name, description, and an author. It's conventional to have a bin folder containing our executables. So we'll create a bin directory containing our main executable. This will be called main.dart. In this file, we'll create a main function in order for our Dart program to run, and we'll print out to the console. Save the file and run. Using the Chocolatey package manager, we can install the Dart SDK by running choco install dart-sdk. Alternatively, you can install the dev channel version by passing the pre flag. To upgrade a pre-existing Dart installation, run choco upgrade Dart SDK. Restart your command prompt in order to confirm your Dart installation. Confirm Dart is properly installed by typing the Dart command and passing the version flag. In your working folder, create a pubspec.yaml file. A pubspec file contains metadata and configuration related to a Dart project. We will enter the minimum information about our project, such as the name, description, and an author. All starting files go in a bin folder. Let's create one containing a main.dart file. In this file, we will define a top-level function called main. Dart requires this function to start our application. Save the file and run. And this completes the lesson. We'll begin by running sudo apt-get update to update the package repository listings configured on our system. Install apt transport HTTPS to allow us access to repositories using the HTTPS protocol. Add the Google Linux sign-in key to your apt key list to allow us to register the Dart repository. You may need to install the curl package if not already installed. And then try the command again. And then register the Dart repository. This will now allow us to install the Dart SDK. To install the development version of the Dart SDK, register the unstable Dart repo instead, and then run the same command to install Dart. You can confirm you have Dart installed by going directly to the bin directory. After installing the SDK, add its bin directory to your path environment variable. Now you should be able to use the Dart command directly. In your working folder, create a pubspec.yaml file. A pubspec file contains metadata and configuration related to a Dart project. We will enter the minimum information about our project, such as the name, description, and an author. All starting files go in a bin folder. Let's create one containing a main.dart file. In this file, we will define a top-level function called main. Dart requires this function to start our application. And in this function, we'll print the current date time. Save the file and run. And this completes the lesson. In Dart, every type is an object, including the built-in types. Numbers can be defined either as an integer or a double. Integers represent whole numbers, while doubles allow you to define floating point digits. You can also perform the usual operations with these numerical types. Strings can be defined with single or double quotes. Strings have support for template literals by default, which means we can contain expressions inside strings without using concatenation. Another feature of template literals are multi-line strings, which you define with triple opening and closing quotes. A recommended way of concatenating long strings is to use the adjacent version. So instead of having the pluses in this example, we could do without. And in fact, if they're very long, we could have them on separate lines. Let's print these out to the console. Booleans are values that are set as either true or false. Apart from simply printing these out, they could also be used in various operations. Functions are self-contained program segments that carry out a specific task. Functions can also be set as a value to an identifier. Here's an example that calculates the difference between two integers. And there's also a shorthand version. A list is a collection of elements with a length. These have similar syntax to other languages. List types also come with a utility of methods to iterate over its elements. Maps represent objects that contain key and value pairs of data. Keys can be accessed using array bracket notation and iterated over using methods like for each. Runes allow you to contain characters that are outside the UTF-16 set of characters, for example emojis. Here's an example. And then using the fromCharCodes method of the string constructor, we'll pass in our input. Symbols are a human-readable string that represents an identifier of sorts. These identifiers could be library names, instance variables, and methods, for example. We can create symbols using the symbol constructor or the symbol literal syntax. Let's run. Here's an example of a variable. Dart is able to infer the type of value assigned to our variable, which in this case is an integer, although we could be explicit by declaring the type. We can also set constant values, which essentially are values that cannot be changed once they are set. This comes in two forms. There's the final keyword, and if we attempt to reset this to a different value, we will get an error. The second form of declaring constant values is using the const keyword. The difference in practice between const and final is to use final when setting instance variables belonging to classes. Also, const is treated as a compile-time constant, which means that any value we assign will be calculated during code compilation. Const variables must therefore be initialized with a valid const value, or an exception is thrown. Some of the valid const values are number, string, boolean, array, map, symbol, and any constructors marked as const. Apart from parameters that are required, functions or methods in Dart can also specify optional parameters. These come in two flavors, positional and named. The required parameters are listed first, followed by any of the optional parameters. Optional positional parameters are defined inside opening and closing square brackets, separated by commas. The exclaim parameter defaults to null. Let's specify a default boolean and add another parameter. Optional named parameters are defined inside opening and closing curly brackets. Using optional named parameters will help you define functions and methods that are self-documenting. Here's how you would use these in the case of methods. Let's invoke our method. Let's refactor our method example with named parameters. Update the method call. Run again. Control flow statements are possible with Dart in the following forms. An if statement allows us to evaluate a condition and decide what to do depending on its outcome. The else block is optional, which reflects behavior similar across most programming languages. The condition we are evaluating must explicitly result to a Boolean value, else an error is thrown. You can also chain your if statements. You can write the statement in its short form using the ternary operator. Dart supports various for loops with a familiar syntax. We can also capture the values of the current loop index inside a closure. When working with iterable types like list and set, you can use the for each method to loop over its items. You could also use a foreign loop for iterable types. The while loop can be used as an alternate form of the for loop. Use a do-while loop to ensure that the print logic runs at least once. Use a break statement to stop a running loop. And use continue to skip the current loop iteration. Use switch and case statements for comparing integers, strings, and compile time constant values. Here, the break statement stops further execution of the switch statement. Omitting the break will give you an error unless you are falling through to the next block within the sequence. Use an assert to disrupt code execution if the given condition evaluates to false. Pass a string as the second argument to attach a message to the assert. And this concludes the lesson. Classes allow you to define a blueprint that represents a particular object. In this example, we are creating a blueprint describing a person. Creating classes has similar syntax to other languages, and this is by design. In the person constructor, we accept the name and age parameter, assigning its values to our instance properties, name and age. There is a simpler form of assigning these values with shorthand constructors, and we can also be specific about our instance property types. You can declare private instance properties or methods by prefixing them with an underscore. We can also define getters and setters for our name, private property. Languages like Java allow you to specify multiple constructors for a class, differentiated by the amount of parameters defined for each constructor. In Dart, however, we can use named constructors without worrying about the parameter count. Parameters can also be optional for the constructor and its methods. Alternatively, use the optional positional parameter. We can override several operators to perform various tasks like arithmetic and comparisons. In this example, we'll override the equal operator. Let's create a match and Jane object and compare. Classes are extendable using the extends keyword. To demonstrate this, we'll create an employee class extending person. This will inherit instance variables and methods from person. In this constructor, we will pass the name and age variables to the parent person constructor using the super method. We can also override the methods from the parent class. Fields that won't be changed once they are set can be marked as final. Attempting to change a field marked as final will return an error. A feature supported when instantiating classes are method cascades. These allow you to adopt a chaining pattern when invoking methods and setting values. So instead of doing this, you could instead use the cascade operator. Let's run this again. An interface provides a contract containing instance variables and methods that must be defined by the class that implements it. To create an interface, define a class or an abstract class. Classes in Dart have the flexibility of either being extended as a parent class or implemented as an interface. Let's now write a class that implements our interface. Let's define our constructor that accepts a name and manufacturer as parameters, which are automatically assigned to the name and manufacturer instance variables. Let's now implement the getDeviceInfo method from our interface and instantiate this class. Mixins allow us to reuse a class's code in multiple hierarchies without polluting our inheritance tree. We can define a mixin by creating a class. We can now share this mixin on our phone class using the with clause. This now allows us to access the properties on our mixin. As of Dart 2.1, it's recommended to use the mixin keyword as a convention. Mixins are similar to classes and therefore can be extended by other mixins using the on keyword. Utilities mixin can only be used when features mixin precedes it, else an error will be thrown. Let's add some methods to help print all our features in utilities mixin. Then we'll print this out. We are also able to access properties and methods from our parent mixin using the super keyword. Let's refactor getDeviceInfo in our phone class and run again. Futures allow you to capture a value or error that will be returned at some point in time. These operate in a similar fashion to promises if you've worked with JavaScript. Here's a basic example of a future object that returns a result at some point. Running this returns a string label that represents the future instance rather than the actual result. This happens because futures work in an asynchronous manner. We need to use the then method to capture the result once the computation is complete. Here's another example that adds a delayed period of time before returning the result. Use the catch error method to handle exceptions. You can also chain your success and error methods. We can chain as many then blocks as possible. To demonstrate that, let's create a variable called showError, which will be used to trigger the catchError method callback. Then let's modify the computed result with this variable. In our first success handler, convert the result to a map object using the JSON decode method in the Dart convert library. Dart libraries are also feature-rich with functions that return future objects. Here's an example using the HTTP request getString method to make an API call. This works as expected as long as a feature is returned. For asynchronous functions that are not based on the feature API, we can use the completer class to wrap it within a feature context. To demonstrate, let's create a function that accepts a callback function to be triggered once an asynchronous operation is complete. To wrap this function so that a feature is returned, we can use the completer class that comes from the Dart async library. Create a wrapper function with a return type set to future. Create a completer object and return its future. Before the return statement, run our lookup version operation. In the callback function, we can resolve our future by invoking the complete method on our completer object. To trigger the catch error method call, use the complete error method. Future-based APIs can also be used with async await syntax. To do that, let's create a function, marking it with the async keyword before the opening curly bracket. For any function returning a future, prepend the await keyword before invoking it. Let's invoke this function. To handle exceptions, wrap your await calls in a try-catch statement. Then modify lookup version as future to respond with an error. Let's run again. And let's pass this one more time. And this concludes the lesson. Streams represent a sequence of data events that occur while reading information from a data source. Streams are especially used when dealing with data sources like HTML events emitted from button clicks or reading data from a file. To demonstrate the concept of streams, we will use the stream controller interface. This will help us handle streaming data as well as invoke events by feeding data into the controller. The stream is exposed through the stream property, which contains the listen method for handling streaming data. To invoke a data event, use the add method to feed data to the stream. Let's run this example. A stream controller is also a generic class, which means that we can specify the type of data we expect to be handled in the stream. We can also listen for errors and done events on the stream. To invoke the onError handler, use the addError method. To invoke the onDone handler, use the close method. Calling the close event also returns a future, meaning we can add a then callback method. Let's refactor with async await syntax. There are two types of streams in Dart, single subscription and broadcast streams. The example we've seen so far is a single subscription stream. This means that we can only attach a single stream listener event. Attempting to add another listener will throw a runtime error. With a broadcast stream, we can implement more than one listener. To create one, invoke the asBroadcastStream method. And let's write some listeners and feed some data to them. We can also use async await syntax to listen for streaming data. Streams can be created from generic types such as futures. To demonstrate, let's create a future. And using the FromFuture constructor, we can produce our stream. Let's add our listener. And run. We can also implement basic error handling by defining an onError handler. Let's trigger this error by using a wrong endpoint. We can also add a list of futures to the stream. To demonstrate, let's add another API call that returns a future. And then using the FromFuturesNamed constructor, pass a list containing both futures. And listen for the result. Streams can also be created from iterable types like lists or set. Here's an example of a stream produced from a list using the fromIterableNamed constructor. Then we will listen for each character fed to the stream. Let's run. One useful application of this would be simulating a typing effect using a timer. And this concludes the lesson. Dart manages packages using a tool called pub. To use packages in your project, create a pubspec.yaml file at your root directory. The simplest detail you can add to your pubspec file is the package name. Optionally, you can add in a description, version, and author. To pull in external packages, define the dependencies key, followed by a list of dependencies. Running the pubget command reads the dependencies listed in the pubspec file and installs them in a central location on the operating system. You can also specify a package version by defining a version constraint. A .packages file is generated with details of the packages installed and their location on the system. This file is not to be committed to version control as the system cache location differs depending on what operating system you are installing your packages. Dart package versions use the semantic versioning format. So far, the package version is set as concrete, which means that exact version is pulled into our project. Using the greater than equal symbol followed by the version number allows the provided version or any greater one. Using just the greater than symbol followed by the version number allows any greater version, excluding the given version number. Running pubget throws an exception because the path module has no greater version than 1.6.2 at the time of this recording. Using the less than equal symbol allows any version less than or equal to the provided version. Removing the equal symbol allows any lesser version excluding the provided version number. Now, because the current Dart version at the time of this recording is over 2.0, there is no version of the path package below 1.6.2 which supports the current SDK version. Let's comment that line out and try again. We can also specify a range of versions. Here, we are saying that we want a version greater than or equal to the provided version while excluding the next major version, 2.0. In fact, we can simplify this by using the caret symbol. Set the environment details to ensure the package pulled in is compatible with the given Dart SDK version constraint. You can define dev dependencies for packages that are only used during local development. To work with installed packages, use the import syntax followed by the package prefix and name. The Dart runtime will look up everything after the package prefix in the .packages file. Let's run this Dart file. Use the as keyword followed by a key to create a namespace for the imported package. This style can also be used to import files from the current project. To demonstrate that, let's create a file in the lib folder and define a function to return the current timestamp. Returning to main.dart after the package prefix, use the package name you specified in your pubspec file, which will point to the files and folders in your lib directory. We should now be able to invoke our top-level function. To upgrade your dependencies to the latest version, run pub upgrade. You can also upgrade a specific package by running pub upgrade followed by the name of the package. The Dart toolbox contains utility methods for working with strings as part of the Dart core library. Use the contains method to check whether the specified text exists. You can pass in a regular expression to enhance your search. To check whether the string starts with a particular character or set of characters, use the starts with method. To check whether the string ends with a particular character or set of characters, use the ends with method. To convert the string to its uppercase and lowercase formats, use the to uppercase and to lowercase methods. Strings can also be split into an array of strings using the split method and passing it a delimiter. Use the split map join method to split a string into an array of strings, perform transformation on each item, and return the joined output. The first argument takes a pattern to match for. The second argument is a named parameter called onMatch, which allows us to perform transformation on our matched pattern. The third argument is a named parameter, which allows us to perform transformations on non-matches. You can enable the multi-line option for our regex if you wish to affect each line. To retrieve the positions of the first and last matches of a particular string, use the index of and last index of methods. Use the trim method to remove any leading and trailing white spaces. Here's what it looks like without using the trim method. You can pad a string using the pad left and pad right methods if the string length is less than the specified value. Last but not least, you can replace a part of the string that matches the specified pattern. And here's how to do the same using a regular expression. If you wish to retain any captured groups from your regular expressions, use the replace all mapped method. Then we'll wrap the first captured group in the curved braces. And this concludes our lesson. The Dart toolbox contains utility methods for working with lists as part of the Dart core library. Use the for each method to iterate over each element in a list. Use the map method to produce a new list after transforming each element in the given list. Calling the map method returns an iterable, which is the base type for Dart collections. Use the toList method to produce a list type. Use the contains method to check that a given element is in the list. Use the sort method to order items in a list based on the provided sorting function. Use the reduce method to compress the elements of a list into a single value. If you wish to provide an initial value, use the fold method instead. Use the every method to test whether all the items in a list satisfies the provided condition. To return a collection of elements that satisfies a particular test, use the where, first where, or single where methods. And here's how we'll use first where. And single where. The first where and single where methods receive a named argument called or else. This allows you to define a callback that is invoked when no matches are found. Failure to define this named argument will throw a state error when no matches are found. You don't necessarily have to return null, as you could return an item which is of the same type expected, in this case being a map. Use the take and skip methods to produce a collection while including or excluding elements. It's also possible to chain the take and skip methods. Use the expand method to expand or flatten a list into one or more elements. Here's another example duplicating the items of a list. Use the list.generate factory constructor to generate a list with a specified length. Generated lists by default are growable, which means that they can be extended. If you wish to disable this, set the growable option to false. Use the list.from factory constructor to clone the contents of a list. And this concludes the lesson. Extension methods are a new feature added from Dart 2.6 to enable the addition of new functionality for classes and interfaces without directly changing the original interface or creating a derived class. To understand this concept a bit better, let's walk through an example. I'll create a top-level function called getDuration that takes in an integer and produces a duration object from it. And we can invoke this in our main function. The result is a duration object set to exactly 2 seconds, and we can pass the result to a delayed future, for instance. Although this gives us the intended result, extension methods are able to provide us with a cleaner approach by extending the integer type with a getter that returns a duration object. To do that, we can use the extension keyword followed by an identifier for our extension. So here we are extending the int type. We will define a getter called seconds, which will return the duration object. The this keyword refers to the integer value, so in our main function we can now use this method as such. We can also use the identifier from our extension type. Let's refactor our delayed future to improve legibility. We can define extension members for instance methods, operators, getters, and setters. We will define a months ago method that will subtract a number of months from the current date and use it like so. Let's try another example with the string type. We will implement an instance method that checks that the provided string is a valid email address. And let's use it as such. And let's test with an invalid email. It's worth mentioning you cannot add instance fields or else an exception is thrown. Let's have an example with a setter. We can define an extension member called latest on the stream controller class. And now let's instantiate a stream controller and add a listener to the stream. And we'll use our setter as such. Let's run this one more time.